In this video we're going to look at the second lot of organic chemistry questions, and this is the first of the longer non-multiple choice questions. So butan 1-ol can be oxidised using two different methods, and in this one, looking at the information that's been given, we've got it added to acidified potassium dichromate and the product is immediately collected by distillation. So that is telling me that I'm making the aldehyde, not the carboxylic acid. And then I'm going to write an equation for this oxidation, showing clearly the structure of the product and stating the colour change. So that kind of shows me where my 3 marks are, one for the equation, one for the structure of the product, and for the colour change. So although it wants the structure of the product, it's not given me any specific details on how it wants everything, so I don't necessarily need a displayed formula. It may well be that you prefer to write a displayed formula for butan 1-ol. Alternatively, you could have gone even more simple and just gone for something such as C4H9OH. I would recommend, if you're going to use a very shortened structure, that you show the OH group. However, don't, for example, just write C4H10O because it's just not as clear that it's an alcohol. Shortened structural formula like the one there that I've done there is probably the best way forward because it's the quickest to do, but it still shows very clearly that it's butan 1-ol, so it shows me that it's primary alcohol. And I'm going to add my O for my oxidizing agent, and again, showing the structure of the product doesn't necessarily mean I have to do the whole thing in displayed formula, but you might have done, and that's absolutely fine. But when I get to the 4th carbon, I do this time want to show that it is an aldehyde, so you might just want to put the lines in between. Because you're doing that, I've just done that to be a little bit quicker. It could be that you want to do a full displayed formula. The important thing here to finish off the equation is to remember that you're making H2O. So you're removing hydrogen in order to make that C double bond O. You're removing 2 hydrogens, you're putting them with the oxygen that we've got in the square brackets to make H2O. So that's now balanced. I've done the equation, which is correct, and I've shown the structure of the aldehyde rather than writing COH or CHO. So I've got 2 out of 3, and the last one is for the colour change. So we need to say that it starts orange and goes to green. Make sure when you're asked for a colour change that you don't simply write one colour. You're meant to say what it starts as and what it ends as. Next bit, it says explain with reference to the intermolecular forces and relative boiling points why the product can be easily separated. So we're talking about the organic reactants and products, and so it might just be easier to draw them skeletal. And by the way, you could have drawn them skeletal in the previous example as well, because you're still showing the full structure of the aldehyde by doing that. So using that, we can see that butan 1-ol has hydrogen bonding as the strongest intermolecular force, whereas butanal only has permanent dipole attractions, and therefore butan 1-ol has stronger intermolecular forces and requires more energy to overcome those forces, break those forces, however you want to say it, more energy to turn into a gas, anything like that. So we're just linking the 2 different types of intermolecular force, identifying which one is stronger, and therefore saying that that one requires more energy and thus has a higher boiling point. So we're really just linking it all to boiling points. So actually I might, just to make it really specific to the question, say that butanal has a lower boiling point. I probably don't need to write every single one of those things for 2 marks. So simplifying it, butanal has a lower boiling point because it has weaker intermolecular forces, because butan-1-ol has hydrogen bonding and butanal doesn't. Okay, then the next one, it said it's an extension question, but really it's just a different question. It's just more about redox than it is about organic chemistry. So dichromate ions are reduced to chromium 3+. So I'm going to do the formulae that I've been given. Do an arrow, leaving lots of space for potential things that I need to add to balance. And then I'm going to create a half equation for this reaction. So first thing I need to do is balance the atoms of the chromium, so ignoring hydrogen and oxygen, just sorting out the chromium first. 2 chromiums on the left, so I need 2 Cr3+ ions. Next thing I do is balance the oxygen using water. 7 oxygens on the left, so I need 7 waters on the right hand side. Next step is to add hydrogen ions. There are 7 waters, so there are 7 H2Os, so I need 14 hydrogen ions. Last step is to balance electrons. Remember, there are 2 ways to do this. Via oxidation numbers, I've got 2 lots of chromium 6, so that's 2 lots of 6+ going to 2 lots of 3+ on the right hand side. So overall, each chromium is decreasing its oxidation state by 3. So altogether, to do that, I'm going to need to add 6 electrons because there are 2 chromium atoms each going down by 3. Check the charges. So on the left, 2 minus, 14 pluses makes 12 plus, 6 minuses makes 6 plus, and on the right, 2 lots of 3 plus makes 6 plus. So it's balanced. That one would be worth 2 marks because there's a lot of things to sort out in terms of the hydrogen ions and the electrons and everything else. Next part, it says write half equations. For this case, we're going to do the oxidation. So that was the reduction because the chromium was going down in oxidation number. So now we're going to do butan-1-ol, and we're still doing butan-1-ol going to butanal. Here's where it might be easier to just simplify the formula a little bit. So C4H9OH. Butanal would be C4H8O. So because I'm not really trying to work out any formula here, the important thing is I've just lost 2 hydrogens. So I haven't changed the number of oxygens, so I don't need to add water. My carbons are obviously fine, I've got 4 on each side. So the only thing I need to balance is the hydrogens, and I've got 10 hydrogens on the left and 8 on the right, so I need to put 2 H pluses. If I've done that, that tells me I need to balance electrons as well, because I've now got charge on the right that I don't have on the left. I could sit and work out the oxidation numbers, but with there being 4 carbons, oxidation numbers are going to be a little bit like averaged out over the molecule, so you might just go for trusting the fact that the carbon that has the oxygen on it has become oxidized and has become 2 lots more positive because it's now forming a double bond with the oxygen. Okay, how we then combine them is we need to balance the electrons so that they cancel out. So we've got 6 electrons on the left hand side for my reduction, 2 electrons on the right hand side for my oxidation. So I need to take the second equation and times the whole thing by 3 to get 6 electrons in the second equation as well, and then when I add them together, those electrons will cancel out and I'll get a full equation. So I've got 3 for my butanol, butan-1-ol, 3 molecules of butanal, 6 hydrogen ions, 6 electrons. Adding all of that up, I will get Cr2O7 2 minus. I'm just going to add, so I've done that bit, tick it off. I'm going to add my 3 molecules of butan 1-ol, tick that off. What else have I got on the left? Well, I've got 14 H pluses, but actually I'm just going to check on the other side, because on the other side I've got 6 H pluses. So I'm going to take 6 H pluses from both sides, which means I get rid of those, and my 14 H plus now will become 8 H plus. 14 take 6 is 8. So I only need 8 H pluses, and the whole point of multiplying the bottom equation by 3 was to get rid of my 6 electrons, so they've been cancelled out as well. So that's everything that I need for the left hand side. On the right hand side, therefore, so I've done my H plus, I'm going to have 2 chromium 3 plus ions. I'm going to have 3 molecules of butanol and 7 molecules of water, and now I've accounted for everything that I haven't already cancelled out. Last part of this question then, this time we're taking acidified potassium dichromate and heating it under reflux. Draw a labelled diagram of the apparatus. So what are we looking for in the diagram? It's only 3 marks and it doesn't have to be a work of art. So the flask should be either pear-shaped or round-bottomed, but we shouldn't be drawing really conical flasks or anything even weirder like beakers or test tubes. Conical flasks are great for mixing things, but they're not great for heating things. You want a shape that distributes the heat. Speaking of which, you need some heat. Easiest thing is just an arrow. You might want to write the word heat since it says labelled, but certainly don't need to be drawing a Bunsen. Probably wouldn't use a Bunsen because of the flammable liquids. Don't forget to put something in your flask. So don't forget to put a line just to show there is something in there. So how are we going to draw the condenser? I'm not going to bother trying to do the transitions between one piece of equipment and another. So I know that the condenser doesn't really magically fuse onto the top of the flask, and that there are clips and that everything else, you know, you may see more pretty diagrams. The main thing that I've done here is just make sure there's no gaps and that I haven't sealed it off, and that basically if you look at the top of the liquid, the gas can go up into the middle of that condenser. Round the outside, just kind of showing something to show that there is like a jacket of water around the outside. Again, you know, a really good diagram would have a little gap there and a little gap there for the water to go in and out. But other than that, what am I getting the marks for? Well, I'm getting the marks for some sort of flask with a condenser. That would be 1 mark. Let's label it. Flask. Label. There's not many labels because there's not much apparatus. Key label though will be the water in, water out. That's always important when you've got a condenser. So at the bottom you have your water in, at the top you have your water out. That is one of the marks, the correct labelling of the condenser. The other 2 would be for having the right apparatus, having a condenser in a flask, and the third one would be for making sure that when your liquid turns into a gas, that it can go, I've chosen rather large circles for that, up the condenser with nothing in the way, so there's no sealing points there, and there are no points around here where the liquid could escape as a gas or anything or go somewhere else. So don't block the condenser. Labels just means mostly water in, water out. Not important to draw a clamp. All apparatus in chemistry diagrams floats magically and is self-supporting, and you never really have to draw a clamp stand because it's just too difficult to get it in when you're doing a cross-sectional diagram. Last part was naming the product. So butan 1-ol is going to be fully oxidised to the point where the last carbon is going to have a COOH group. There's no marks for drawing it. the name would just be butanoic acid. No need for a number. Carboxylic acids can only be on the first carbon